Good evening and welcome back to the current affair lectures that we have been doing. So we have taken three very important topics today that are from science, science and tech, and one is from the topic that we are having at hand today, NASA's Artemis program. This has been in a lot of news, mostly because the intended launch of the satellite Orion that was being sent through this SLS system, satellite launch system of NASA. The very recent development in the NASA's field of launching the satellites, that has actually failed. One of the sensors failed in that launch, and that launch has to be aborted. It was happening on this Monday, but now it is scheduled to take off this Saturday. Okay, so that is the news. So Artemis, NASA will try to launch moon rocket on Saturday. Now this is a moon rocket. What we have seen in the last decade, that NASA has primarily focused a lot upon the Mars exploration. Now whenever there is a government change in USA, the policy of NASA also changes, because NASA primarily subsists upon the budgetary funding from the US government, and hence it has to align itself to the policy directed by the political executive. Like Barack Obama's focus was exploration of Mars, whereas Trump's focus was bringing back to moon, okay, and primarily establishing colonies on moon and then utilizing moon for commercial purposes. Now why is moon important for commercial purposes? Recently we have found that the north and south poles of moon have a lot of water in the frozen form. Okay, now that water can be used if human colonies are settled there, and that water can be used for a larger exploration of moon, because to settle human colonies we need water. That is the most fundamental, most foundational thing for a settlement to exist on any planet, because we humans or any creature that lives on earth, we have been designed, we have been developed, we have evolved in such a way that we cannot survive without oxygen, water and all these things. Okay, now there's also a question that can the extraterrestrial creatures that we are speculating about, or these NASA and ISRO, all they are looking for, do they also necessarily need oxygen or water and all these things? So the answer to that question is not necessarily, because the extraterrestrial creatures that we are looking for might not have the same characteristic, the same body structure, the same existence, the same chemical structure as we do. Okay, but they can also exist through different other processes like chemosynthesis, okay, taking food from chemicals and all. Okay, so now, but moon is having a large deposit of important minerals that we need here on earth. Okay, and moon can become moon exploration is primarily important for our mineral needs. Okay, secondly, moon can also function as a laboratory where we can test our satellites, where we can test our the astronauts that we are to send to the Mars. Ultimately we can test their living conditions there, and we can simulate the living conditions of Mars on moon, and we can use moon as a test bench for our Mars missions as well. That is why moon mission is very critical. Now Artemis, why the name Artemis? Artemis is actually the Greek god moon. The moon has been referred to as Artemis in the ancient Greek, okay, and it was the god of moon who was worshipped. Okay, that is why it has been, the whole mission has been termed as Artemis. Now as you can see, this is very important development in the field of rocket launch, because SLS satellite launch system is the heaviest thrust generating machine that has ever been developed on the planet. Okay, that has ever been developed on the planet. This satellite rocket launch system, this is immensely huge, and the amount of thrust that it generates in the initial phase of launching, that is very high, so that the payload capacity of this rocket is very high. Payload capacity means the amount of weight that it can carry onto the carry out of the Earth's gravitational pull. Okay, that is called payload capacity. Now Artemis 1 was, what is the news? This is a photo from the NASA's Cape Canaveral launching pad. Okay, the Artemis 1 was scheduled to be launched on Monday, but due to some technical failure, actually there was one technical failure of a sensor which failed to cool down. That sensor failed, and hence the cooling mechanism of one of the engines got failed, and due to which it has to be stopped. Okay, so what we know for now is that Artemis mission is primarily for it is being launched for moon. It is not being launched for Mars, as we saw in one of our previous lecture about the Perseverance rover. The Perseverance rover and Ingenuity flight helicopter was launched for Mars. Okay, so Perseverance rover and Ingenuity flight helicopter, flight demonstrator, actually it was a very small helicopter that the NASA scientists were trying to test if a drone kind of thing can be used to explore the Mars or not. Why? Because the atmosphere of Mars is very thin. Okay, and to generate thrust by pushing the wind down, okay, the usual process which drones or helicopters uses, they push the wind down through their rotatory blades. Okay, and when the wind is pushed, according to the Newton's third law, the body is pushed upwards, lift is generated. Okay, to test that specific ability, because the atmosphere of Mars is very thin. Okay, so the amount of thrust generated, because the amount of wind present there is very low, because the atmosphere is already thin. Hence, the amount of force required to generate lift will be very high on Mars. Okay, so that technology demonstrator Ingenuity was sent along with the Perseverance rover, and we have discussed that in great detail. Okay, now this is a very important slide. We would try to understand how the colony, how Artemis mission, basically Artemis mission is divided into three stages. Okay, three phases. The first phase, the Artemis 1, the second one Artemis 2, and the third one is Artemis 3. Now Artemis 1 is a technology demonstrator. Technology demonstrator means it is being used, it is, first of all, it is not a crewed mission. Crewed mission means no person is being sent on this mission. No human is being sent on the mission. And second of all, it is a technology demonstrator. It is a technology demonstrator for testing the Orion capsule that will be used to launch humans in the next phases. Okay, in the next phases of Artemis 2 and Artemis 3, right? In 1960s, NASA sent Apollo missions to moon. Okay, and Apollo mission was the first person to to put his steps on, or put his foot on the moon, was Yuri Gagarin and Neil Armstrong. Okay, basically Neil Armstrong was the first person who put his foot on the surface of the lunar surface, of the moon, and Yuri Gagarin was also the part of that flight mission that went, and the first mission that, so it happened way back in 1960s. So now around 50-60 years have passed, and we are sending again, our focus has come back again to the moon. Why? Because those missions were the very beginning missions. Technology was not very advanced, and NASA was testing it. It was kind of a space race between USA and USSR, that time Russia. Okay, Russia of this time, USSR of that time. Okay, now Artemis, that mission was a pioneering mission, in the sense that it tried to establish the human foot on the moon. Okay, and now these missions are critical missions, in the sense that they are going to not only put the human foot on the moon, but they are also, the ultimate aim of this Artemis mission, phase 1, phase 2 and phase 3, is to establish human colonies and establish a gateway to the deep space exploration. Okay, moon is not very far. It is around 2.7 lakh kilometers away. I believe less than that, but still moon is not very far. Mars is far, and this deep space beyond that is even far, right? Though if we have our apparatus on Mars or moon, so we are also going to be able to explore the space from different angles as well, right? And that might reveal the newer insights that we might not have been able to view from our own planet. So Artemis 1 will be, first of all, it will contain actually three parts. The first one is this Orion spacecraft. Orion spacecraft. Okay, as you can see, this is a spacecraft along with an engine. It is a spacecraft along with an engine. Okay, it is not merely a capsule for humans to go. It is a spacecraft with an engine, and you can see the solar panels. That is not important. What I'm trying to tell is that this spacecraft will be having it will be having a very strong engine with itself, and it can fly for a very long period of time without even docking into the International Space Station. Now, what I'm talking about International Space Station, International Space Station is a space station put in the lower Earth orbit of Earth. Okay, lower Earth orbit of Earth. It revolves around Earth constantly. Okay, and all these launch vehicles. Okay, and right now what we do is we send our astronauts to the International Space Station to conduct scientific research. Okay, and our satellites that go there, they do not have the enough capability to survive for a very long period of time without docking at that International Space Station. Now, why docking? For refueling and all these purposes. But this satellite or this spacecraft, basically it is not satellite, it is a spacecraft. It will be having more fuel capacity and more perseverance, in the sense that it will be able to sustain without even docking into the International Space Station for a very long period of time. Okay. Now, Artemis program, Artemis program, as I said, has been divided into three parts. Okay. We'll be returning back to this slide in a while. Artemis program. Artemis will be the first integrated test. Integrated means it contains at least more than one elements. Okay, the mission has more than one elements. The first one is the Orion spacecraft, space launch systems, and the ground system at Cape Canaveral, Florida. That means it will be a testing. It will be a testing of three important things. The first one is the Orion spacecraft that we can see here. The space launch system rocket, that is this rocket, because this rocket has been designed by NASA and it is having very immense thrust. Okay, so and it is the most powerful rocket that has been designed by any organization on the planet of Earth. Okay, so the testing of it will also be like this rocket will also be tested along with the spacecraft. This white portion is called payload, or the spacecraft that we see here. The spacecraft that we see here is actually placed inside this white module. Okay, and the rest of all, it is actually rocket, which will be ultimately discarded. Okay, that means this portion will get burned out, and this portion will open up, and the Orion spacecraft will come out of it, and it will fly for a specific trajectory that we are going to see in a while, and then it will come back to Earth. Okay, I hope you understood that. Now, NASA's deep space exploration systems are the Orion spacecraft, the space launch systems, and the ground facility that has been developed to monitor this whole space launch facility, to monitor the incoming data from Orion spacecraft and everything. That will also be tested. Okay, it will help the scientists at NASA to understand, and actually this mission is a joint mission of NASA, European Space Agency, and Japanese Space Agency, that is JAXA, JAXA. JAXA. JAXA is the Space Exploration Agency of Japan. ESA is the Space Exploration Agency of Europe, and NASA is the Space Exploration Agency of United States of America. Now, Artemis 1 will have the scientists at NASA to understand this Orion spacecraft will go way beyond moon. It will travel way beyond moon, and then it will come back to Earth using specific trajectory paths, and the data it will collect. Okay, the data it will collect will be very important for the future deep space exploration missions. Okay, it is a 1 month long journey for this spacecraft that is going to take place. Now, Artemis 2 will be it will be a crewed flight, very similar to Artemis 1. It will be a crewed flight, but the difference will be it will be a crewed flight, and it will also establish a gateway. It will also establish a gateway. We'll look at what gateway is. Okay, and then Artemis 3 will be establishing the colonies. Okay, now let's look at what Artemis 1 actually is. Artemis 1 will, now the mission we are talking about. Okay, Artemis 1 will send the rocket without a crew, as we have said, will carry two mannequins designed to study the effects of space radiation on the women's body. Okay, because there have not been a lot of women that have become astronauts. Okay, one was Kalpana Chawla. In one other Indian was Sunita Williams, and other women also have become astronauts. But the point here is that this mission is not restricted only to the International Space Station. International Space Station is actually very close to Earth. It is not very far from Earth. Okay, it actually resides in the lower Earth orbit. Okay, but this mission is going to be very far from Earth. Okay, it might also, like this Orion spacecraft will also leave the Von Allen belts. Von Allen belts are specific belts around Earth created by the Earth's magnetic field that protect our planet from radiations. Okay? But once Von Allen belts are crossed, any body that goes beyond Von Allen belts, then the radiation effect is very high. Okay, so these two mannequins means dummies, for example. So these two mannequins will be also sent, which will simulate the women's body, and the effect of the radiation will be studied on these mannequins, so that more number of women can be put into the can be used in this space exploration. Okay, the third important point is that it will also try to put a person of color, like blacks and brown and all people of color, into the space. Okay, I hope you understood that. Now space will launch on SLS, satellite launch system, that is the rocket, the most powerful rocket. It will travel 2,80,000 miles from Earth over 4 to 6 weeks. It is around 1 to 1.5 month whole period. Okay. Now this is the Artemis 1 trajectory. This should be very inspiring. This should be very interesting as well. Why? Because it shows us a lot of things. See, this is the point Florida in USA that is sending the rocket, and this is the moon. This white line, very faint line, shows the straight path between Earth and moon. But no satellite is being sent using this path. No satellite is being sent using this path, because this path, if we send, although this is the smallest path between moon and Earth, because it is the smallest path, because it is connected by a straight line, but we are not using this path. Why? Because this path will be a steep climb. It will be a steep climb away from Earth. Rockets do not follow that. A rocket never goes straight from one planet to other. Never. What happens is, these rockets make use of the geometric, the specific orbits. All these orbits are regulated by the gravitational forces of the planets. Okay, and it's a lot of mathematics, Kepler's law and all. So these, what scientists do is, scientists use specific geometric tracks which will utilize the least amount of energy, which will utilize the least amount of energy, because most of these tracks, the work is done by gravity of the planets. Okay, and that is why they will use least energy. Okay, now you can see this green line. This path will be followed by this Orion spacecraft. Okay, it will be launched, and then this is the spacecraft will go. Okay, it will deploy, and then spacecraft will do a pass by of the moon. Okay, spacecraft will do a pass by of the moon, and then it will follow this trajectory. It will revolve, it will go very far away from the moon as well, into the deep space, and then it will follow one trajectory back to Earth. It will fall in the Pacific Ocean. Okay, now I hope you understood this whole trajectory and everything. Now what we are doing is, we are also establishing a gateway. Now what is a gateway? Gateway is, if you try to understand it in very simple terms, now what is a gateway? See, this is Earth and this is Moon. Okay? And this is somewhere Mars. Okay. Now what we do is there are elliptical orbits. Orbit means any circular or elliptical track in which a body revolves or rotates. Okay. Now one such orbit is being followed by Orion trajectory. Okay. One such orbit is being followed by Orion. Now what we will do is we will establish a gateway. One gateway. It is a near rectilinear heliospheric orbit, NRHO. It is not important to remember this. What I'm trying to say here is again Earth, Moon and somewhere Mars. Okay. What I'm trying to say here is one such orbit is there. It is called NRHO. It is this orbit. This is also called gateway orbit. Gateway orbit. Why gateway orbit? Because we are trying to place our gateway into it. Now what is gateway? As we know, there is one such orbit around Earth. It is called low Earth orbit. Low Earth orbit has very smaller height. Okay, it is closer to Earth. Now our International Space Station. Okay, International Space Station flies into this orbit and it always revolves around Earth. Okay. Similarly, this, if any object is placed in this orbit, it will always revolve around Moon. Okay. So like lower Earth orbit for Earth, there is one gateway orbit in which we will be placing a similar body like International Space Station. Now we will be placing another International Space Station here, so that now you can see it is at one point in time very far from Moon, but at another point it is very close to Moon. Okay, so that is why NASA spends a lot of money in studying these orbits, because these orbits, if placed into this orbit, the body does not have to use any of its own energy. It will keep rotating in that orbit around the Moon because of the gravitational pull of the Moon. That is all. It does not have to do anything on its own. International Space Station does not use fuel to move. It moves because of gravitational pull of the Earth. Similarly, if any object is placed in this orbit, it will keep rotating around the Moon without using any fuel of its own. Now we can say that it is a kind of outpost. Okay, it is the kind of outpost. Outpost means we have made our, we have International Space Station, and now we have made a gateway. Gateway means an outpost here. For example, when the moon missions happen, okay, so first satellite will go there and then it will go into this orbit, go on the lunar surface. Okay, now gateway that we are putting here, it will be of great use in many ways. For example, it will be utilized to enable human crewed missions. Okay, human crewed missions, because we do not. What is the main problem of sending a human crewed mission? The main problem is coming back. One can send any mission very far, but the point is, are they able to come back or not? Okay, now coming back is important because of the fuel, because we do not have any such body which can carry so much of fuel that it goes to Mars and comes back, right? What we can do is these specific, this kind of space station that we are putting in the Moon's orbit. Okay, this is Moon surface and this is the Moon's orbit. Now what happens is, if there is a mission going to Moon, okay, then the mission can be replenished. Mission can be some people can be put here, and then they can go back to Moon continuously for making some analysis and studies, and they can also launch some specific machines from there. So it will be a kind of outpost for humans around the Moon, and then it can also be used for the later exploration of Mars as well. Okay, so it will be utilized to enable human crewed missions in the cislunar space, basically lunar space, including capabilities that enable surface missions on the Moon. Okay, it shall provide capabilities to meet. Also, it will be able to. It will be a kind of laboratory around the Moon. ठीक है, तो we can perform a lot of studies as to how we will survive on the moon, because we are very close to moon, right? So it will also fulfill the scientific requirement in the sense that it will also act as a lab, and a lot of things can be tested in that gravitational specific that lunar specific gravity. Okay, it will be utilized to enable, demonstrate and prove technologies. Okay, like a lot of research is going on into the International Space Station as to by like growing food and testing human loss of weight, loss of muscle, loss of bone density in the space, and all these studies can be performed here as well. Okay, in the in the vicinity of the moon, that will help us determine what kind of effects we might face if we go on the moon. So it will help us a lot in establishing lunar colonies in the future. Okay, so I hope you understood that. Oh, okay, one important point that I missed, I believe, was this slide specifically. Okay, now this slide talks about sustainable lunar architecture, like how are we going to colonize moon. Okay, the first one is first lunar space expedition through gateway. Again, there will be a gateway. Gateway means a specific space station put into the lunar orbit or the orbit of the moon. Okay, now we can see pressurized rovers will be provided, specific landing gear will be provided, and all these services will be provided. And these services, the colonies on the moon will be either based on the North Pole or the South Pole because of the presence of water there. Okay, so that is all about this slide, not very much important. If you want, I can zoom it for you so that you can pause and have a look at it. Okay, but not very important. The concept is that we want to colonize the moon now, or maybe we want to use moon for our industrial purpose, even if we are not going to colonize or in the form of human settlements. So at least industrial settlements could be set up there. Okay, so that is all for this lunar Artemis mission. It is going to take off tomorrow, I believe. If everything goes well, then we'll be seeing a very revolutionary launch in a very long period of time. Okay.